Yes.
All right, so this is factoring quadratic trinomials with the lead coefficient 1. So with this factoring technique, what I mean by lead coefficient 1 is that the lead coefficient is the x squared term. This type of factoring only applies to when the lead coefficient or the x squared term has the number before it 1, which we usually don't write that 1. We don't ever really write that 1. So now, before I go into that, let's remind ourselves back when we were learning to multiply binomials, there was a shortcut I showed you when the lead coefficient of the binomials, such as x plus 5 times quantity x plus 2, when those lead coefficients are 1, I told you there was a shortcut. You can use FOIL on these, but there's a shortcut I said that said it was really important to learn because when we get to factoring, it's really how you'll use that shortcut to help you with factoring. The shortcut when you multiply binomials such as x plus 5 and x plus 2 is you do the f just like FOIL, but your middle term, your x term, is the sum of the two constants terms, the 5 and the 2. So 5 plus 2 is 7, and then the last term is the same as what L of FOIL would be, 5 times 2 or 10. So now most of you on the last question we had, you didn't use that shortcut, you used FOIL. And what would you get if you did FOIL? You get x squared plus 2x plus 5x. You see where this 7x is coming from? It's always going to be the sum, the coefficient of this x term is always going to be the sum of these two constant terms if the lead coefficient of the x is 1. All bets are off. If it's like a 2 or that's a 3, then we can't use that shortcut. So what would this one be? Use the shortcut this time. Raise your hand. Okay, Carlos.
X squared.
Right. That's a 6, by the way.
Oh, okay. So x squared plus 2x plus minus 24.
Minus 24. Okay. So what Carlos did there, the f and L of FOIL get the first and last term, but this middle term is like that's the combination of the O and the I of FOIL. But what we're telling you is you can get that coefficient by just summing the constant terms of the binomials being multiplied. So let's do this next one, and then we'll talk about going backwards, which is what factoring is. Okay, somebody else. Michelle, x plus 3 times x minus 11.
X squared plus 3, 13x.
Well, I want you to add the two constant terms. So 3 plus negative 11.
So,
Negative 8x, and then you're going to multiply 3 times negative 11. Negative 33. So if we were to go the other direction, that's what factoring would be. So let's look at this first example. We have x squared plus 5x plus 4. And we want to factor this completely. Well, one thing I want to tell you is to determine the numbers I'm going to have, so when I say factoring, I know that what's going to generate the x squared?
yes.
X next, right? I have addition everywhere, so we know that's going to be plus and plus. Now, what's going to go in these empty spots right there? It's going to be the factors of 4 that sum to 5. All right. What I want you to notice right over here is if I have the factors of 10 that sum to 7, what are those? 2 and 5. Factors of negative 24 that sum to positive 2, 6 and negative 4. See how this is working? Factors of negative 33 that sum to negative 8, negative 11, and 3, right? So I want to factor this first example, I want factors of 4 that sum to 5. Anybody think of what the factors of 4 would be that sum to 5?
1 and 4.
1 and 4. So it doesn't matter what I put, then I can put the 4 there and the 1 there, but that's all there is to it. Now, why didn't I use 2 and 2?
Because it doesn't add up to 5.
Well, right, they would add up to 4. That would be the correct factoring if this was x squared plus 4x plus 4, right? All right, so let's go on to the next example. All right, so next one. So we have c squared minus 9c plus 8. So I'm looking for factors of what?
8.
Of 8 that sum to negative 9. So you've got to be creative here. Factors of 8 that sum to negative 9. How can you get a positive 8 with negative factors? Is that possible even?
Yeah, 2 negatives.
Very good. So 2 negatives. We think of 2 negatives that we can sum, that multiply to 8, but sum to negative 9.
-8, -1, and -8.
Very good, Alicia. -8 and -1. All right. Everybody see how that's going to be the correct factoring? Because if I was to multiply this back together, use FOIL if you want to. I get x squared minus 1x minus 8x. I'm sorry, that's got to be c's, right?
Yeah.
C's. Some c's there.
No,
All right. So c squared minus 1c minus 8c, there's your negative 9c, and then plus 8 when I multiply the negative 8 and the negative 1. All right. Next page. All right. So what am I looking for this time? Factors of negative 24 that sum to 5. Factors of negative 24 sum to positive 5. Well, yeah, what would be positive? Negative 3, negative 2 doesn't sum to, doesn't multiply to yeah.
Oh, wait, isn't 3 and 8 negative?
So 3 and 8, what's the combo?
Positive 8, -3.
Right, positive 8 and negative 3. So far, Alicia is our factoring queen.
Yeah, that doesn't multiply 5.
Yes, it does. So x squared, right? X squared minus 3x plus 8x, there's your 5x, and 8 times negative 3, negative 24.
Alicia. Ooh, kill him.
Okay,
I wouldn't give you my candy.
okay. All right. Now, okay, what am I looking for on a squared minus 10a minus 39?
Back
Oh,
39.
Negative 39.
7 to 10.
Well, there aren't too many factors of 39, right? So,
3, 13, 1,
So
30.
what is
Negative
it?
3 and 13. No, negative 3 and 13. 13 positive 3. Positive 13,
positive 13, negative 3. Good? Okay. All right, now we have a second variable. Don't let the second variable, cause you to lose your mind here. I want you to realize that if there's no number in front of the mn, what number is there?
Negative 1.
Negative 1, okay? So let's not worry about the two variables for a second. I know, here, I'm going to go ahead and I'm going to worry about the second. I know it's going to, the second terms of the binomial that are the factors two are going to have an m and an m and an n and n in the second, first and second terms respectively.
No,
But I want factors of what?
12 and
Of negative 12 that sum to what? Negative 1. So factors of negative 12 that sum to negative 1.
negative 4 and positive 3.
Negative 4, positive 3. Now notice I put the 4 and the 3 with the n, right? Since the negative 12 is with the n squared. Now, how do we know this works? We'll do FOIL if you want to. N squared plus 3mn minus 4mn. There's your negative mn, and then negative 4n plus negative 3n is negative 12n squared. Now, on some of these toward the end, you have to do what's called factor out a negative first before you do the factoring. So we're going to factor out a -1 first. -1 when the lead term is negative. All right, so we're going to factor out a -1 when the lead term is negative. So the lead term is the y squared term here. So I think you'll see why I'm going to do this.
Wait.
So the lead term is this y squared. I don't want to try to factor it with that term being negative, okay? So I'm going to put a -1 out here, right? And now let's just get that -1 out. That's going to change the sign of everything. So what's left?
Y squared, plus 2y,
Minus 15. Now we're going to factor this. We're not going to forget about that -1. That's still a factor. But now we can factor it. So we need factors of -15 that sum to +2. Factors of -15. What is it?
-3 and 5.
Yep. Okay, so we leave that -1 as a factor. It didn't go anywhere. It's still a factor, but now we can factor the rest of it this way. So I have 2 more examples. Question on that? We good? All right. Now, on one like this, you'll notice the lead coefficient is not 1 here. We're going to, when we encounter this, always, even when we learn how to factor ones that don't have the greatest common factor, we're always going to look to see if we can factor out something first. But I want you to look at these 3 terms. Is there a greatest common factor I can factor out?
3.
I'm going to, before I do anything, I'm going to factor out the greatest common factor. Now, what's that going to be? Minus what? TZ, and then plus
4t squared.
T squared, okay? Now, let's focus in here. Three's going to still go along for the ride with the factoring. Any factors of +4 that sum to -5. Factors of +4 that sum to, raise your hand, Heidi?
-1 and 4.
Close, -1 and -4, right? -1 and -4 makes -5, and they multiply together to get +4, right? And now don't forget the t part of this. So z minus 4t, z plus 1t. The 1's there, I just didn't put it, right? Because it's 1t. Look at that and make sure it looks right to you. Because what will these 2 multiply back together to get? This, right? And then I distribute the 3, and I'm back where I started. All right, last one in the notes. All right, so notice I have 4 terms. Does anything look like I could do you see any grouping here where I could group here and do some factoring without trying to factor the whole thing?
The 9 squared.
So I think Ethan has snuffed this out and realizes that let me group this, as long as I can group it like that, okay? So I'm going to group it like that and then take it from there. So what does this factor to?
Wait, that's BB?
That's all right, it's 6B, my 6 ended up looking like a B. There we go, that's all right. Okay, thank you.
Oh, okay.
So we're going to focus on this and then we'll take it from there. It's the hardest kind of problem you'll see in this lesson or in this homework. So this is actually what we call a trinomial square. It factors to a binomial square. But what are the factors of 9 that sum to -6?
2, no, -3 and 3.
-3 and -3. So the factoring of this is going to be b minus 3 times itself, right? b minus 3 times itself, which means b minus 3 squared, and minus c squared. Now, last night's homework, you learned how to factor the difference of 2 perfect squares, didn't you?
Yeah.
So, B minus 3 plus C, B minus 3 minus C. Remember, that's just like if I had x squared minus 49. I go x minus 7, x plus 7. Now, these parentheses really don't have any meaning, so I'm just going to lose them. I'm going to change the brackets to parentheses.
Wait, isn't this what Carlos was saying, like, this is like parentheses, times parentheses?
Yeah.
Yeah.
Well, it's parentheses, brackets times brackets. It's not really parentheses, but these parentheses really have no meaning. I was just showing them because this was what the factoring, the first term, this is like your x squared. You got x squared minus 49. This b minus 3 is like an x, right? So, but then I realized they don't have any meaning, so I don't want to have parentheses inside of the grouping symbols, so I can just clear those. I don't have any right terms, so I'm just going to leave it like that. Okay, those are definitely the hardest ones. There's only a couple like that at the end. All right, good job. I think that's a keeper. Yes.
Sorry, could you do it like the other where you have b squared minus and root 6b plus c squared?
Well, but that would be that'd be going right back to where you started. You'd be going backwards. All right.